Hello and welcome to the 8th video of this series on how to use the TI nSpire. In this video, we're going to be doing everything calculus. We're just going to go through and figure out everything in the calculus menu because there is a lot. And you know on the math test, this new test writer, Mr. Riccardi, really likes his calculus. There's like 10 questions or 10 or more questions of it on every test. And so being comfortable with these functions will really help your success and really help your speed. But you also have to know the limitations. So let's get right into it. So the first thing and the most elementary thing you're going to have to know is how to take a derivative. So there's two ways to get to a derivative. You can either do, or I guess there's three ways now that I think of it. You go to menu and then 4 for calculus and the number 1 for derivative. So let's say I want to take the derivative of x squared. I would type in x and then in here x squared, and then you get 2x. For those of you that aren't as familiar with calculus, you can think of this x right here, as just like the argument. Like whatever variable you put in here, just put that variable down here. For those of you that are more familiar with calculus, you'll know a lot more of like the underlying meaning of that. But if you haven't taken a calculus class and you're watching this, that's what it means for our purposes right now. So the other way you can get there is by clicking this button right underneath the delete. And you get like all this menu, and you see right here, you can get to the derivative that way. So like that. And then personally, my favorite way, and I think the quickest way, is if you just click shift and then minus, you'll get a derivative there. So same thing like that. Something you may want to do is take the derivative at a certain point. There's also a couple ways to do this. You can go to calculus and then number 2 is for derivative at a point. So that's your variable. Maybe I want to evaluate at x equals 3. And then for now we'll just use the first derivative. But I'll click OK and then type in x squared. The other thing you can do is you can actually just type out this extra thing that they have out here. So you see the only difference between the thing I just typed and the thing that you get from derivative at a point is this extra thing out here. And really what that's saying is, oh, I'm just going to plug in 3. But if you're fast and you think this is quicker for you, you can actually just type this here on your own, right? The equal sign is right here. Yeah, I think as I got older, this turned out to be faster. You really should just do a couple of problems. Try timing yourself. Try figuring out which one is quicker for you. But I do like to give you just all the options you have. Okay, the next big thing, like right on the flip side of the derivative, is the integral. So let's say I'm trying to find the integral of x squared from like 0 to 5. Once again, there's 3 different ways you can get there. 1, you can go to menu, calculus, and then number 3 is for integral. Let's say I want to integrate from 1 to 5. Just type those numbers in there. And you get 124 over 3. Remember, if you do Control-Enter, it'll simplify it to a decimal. Or reduce it to a decimal, whatever you want to call it. I believe you can also get to it from here. Yes, right next to all the derivatives, you have this option. Go from 1 to 5 of x squared dx, same thing. Or, once again, my personal favorite is if you do shift plus, that will also give you an integral. That's the one that I use the most often, is that shift plus. I think it's really handy. But you may be thinking, well, on math, a lot of times you have to take indefinite integrals. I mean, sometimes there's questions that the whole question is just take the indefinite integral here. And to do that, all you have to do is just leave the bounds blank. So if I just type x squared in here like that, you see it just gives me the indefinite integral. Of course, there's no plus c. The plus c is kind of implied. But yeah, that's how you take an indefinite integral. Okay, the next group of things is your sum and product, your summation and product notation. So if you go to calculus, number 5 is for sum, And let's say you want to find the sum of like the first 100 positive integers, right? So you type it in just like you would see a function notation, right? I do x equals 1, that's where I'm starting at. 100 is where I'm ending, and I'm plugging it into x. So this isn't a lesson on, this isn't really a lesson on summation notation or product notation. It's really just how do I use it with the calculator. There's many things online of explanations on where this comes from, and I might even make a video myself about that because it's pretty useful. And then the product works exactly the same way. You go to calculus, and then number 6 is product. So let's say I wanted the product of the first 10 integers. Of course, you could just use a factorial for this, but that's how it works as well. You type it in exactly the same way. All right, now for one that confuses people sometimes. So if you've been like on your phone watching this or something like that, pay attention now because this is where it gets a little bit trickier. And that's when it comes to our maximums and minimums. So I'll only cover one of these because once you learn one, you've learned the other. It's just one finds the minimum, one finds the maximum. You type in the exact same thing. So let's say I'm trying to find the minimum of x squared, right? So I would type in x squared, do comma x, and it says, well, of course, that minimum is going to be at x equals 0. Hopefully you can visualize that pretty well. I'm trying to pick easy examples so it's more intuitive, but of course, the math test, you'll probably have more complicated examples. The other thing is that this minimum, it doesn't tell you the relative minimum, it tells you the absolute minimum. And the other, it tells you the absolute maximum, not the relative maximum. So let's say I added a constraint out here. Okay, let's say I added a constraint out here where I want my value of x to be between 1 and 5. Okay, and you might be thinking, right, if you look at the graph of y equals x squared, there is no minimum from 1 to 5. But out of those values from 1 to 5, the smallest value is going to be at x equals 1. So this is the big thing. It does not tell you the relative minimums or maximums. If you want to find that, you can either go to your graph or you can use the derivatives and set m equal to 0, just like you would in calculus. But this is the thing that trips people up. It's not the relative minimum or maximum. It's the absolute. So I suppose you could do an example with the maximum. Do x squared comma x, right? And of course, our max and min is going to be at negative infinity and positive infinity. But if I add this condition, right? There's no relative max, there's no relative max from 5 to 8. But out of these values from 5 to 8, 8 of course will give you the largest one, so that's what it spits out. Okay, on to the next thing. We do have a way of finding the tangent line and the normal line to an equation at a certain point. So you're going to go to calculus once again, and then see number 9 and A rather. 9 and A are for tangent line and normal line. If you don't know what a normal line is basically a tangent line, except instead of touching it at one point and like being the parallel slope, the normal line is perpendicular to the equation at that point. So yeah, once again, you can find that on your own. This is mainly just purely how to use the calculator. So number 9, let's use tangent line. I'm going to keep using x squared just because it's a nice round function. So let's say we want to find the equation of the tangent line to x squared at x equals 3. So I would type in x squared and then comma x. This comma x is just like how you would see in the solver. It's just letting the calculator know, hey, I'm using an x here. So do this in terms of x. And then you do, since we're trying to find what it is at x equals 3, type of 3, and it gives you the equation of the line. Normally you would have to do like a point slope equation to find this, so the fact that this can do it pretty easily is pretty nice. There is one limitation of this, and that's that it will not work for implicit functions. This only works for like your regular functions, like y in terms of x. You may have noticed a couple of questions recently where you had to find the tangent line to an implicit function. I tried to figure out a way to make the tangent line do that, but it didn't work. So you can write yourself a program, you can just get faster at the process, but it will not work for this case. So the normal line is exactly the same, right? You just do x squared comma x comma 3, and that is the equation of the line perpendicular. In fact, I'm actually going to graph these because I think I've done something. Okay, well, I'm actually going to graph these. So this is x squared. There we go. The other line was 6x minus 9. So you can see it's tangent right there, right? That's your tangent line. And then the other one was 19 over 2 minus x over 6. I might need to zoom out a little bit. Yes, okay. So you see, this is x equals 3. That would be 3 comma 9. So you see how this one is tangent, this one's perpendicular? Okay, that was just a little bit of more background on normal line, so you could see it a little bit better. Okay, anyway, that's about that. The next thing is arc length, and once again, this only works for your basic functions, not relations, not like implicit functions. So if you go to calculus, and then we actually have a couple more things down here. So B is going to take us to arc length. So let's say we want to find the arc length on y equals x squared from 1 to 5. So you do x squared, comma x, and then your two bounds, so comma 1, comma 5. I think if you just click enter, it'll give you, yeah, if you just click enter, it'll give you this kind of expanded version, so I tend to like to click control enter. But this gives you the arc length. Nothing too complicated there, pretty straightforward. All right, the next one is your Taylor and Maclaurin series. For those of you that don't know, a Taylor series or Maclaurin series they're basically ways of estimating functions using polynomials. So, for example, there's ways of approximating sine of x using high order polynomials. So let's see what that looks like. If you go down here to series, the only one that I really use for the math test that he talks about is this Taylor polynomial. And here's what you do. Let's say I want to find the third degree Taylor polynomial. The third degree Taylor polynomial of sine of x. So I would type sine of x here, do comma x, and then if I do comma 3, that will tell me the third degree polynomial. Notice third degree does not mean that there's 3 terms. Third degree means that my highest exponent is going to be 3. So if I do comma 5, you see now it's expanded it a little more. If I do comma 6, there is no x to the 6th in the expansion of sine of x, so it just goes back down to 5. This is actually what's called a Maclaurin polynomial. It's called a Maclaurin polynomial because the estimation is centered around x equals 0. So this is actually one I can graph as well. Let me get this back to our standard. This is sine of x. And I'm going to copy this. Actually, it'd be kind of cool if I'm going to do this. So you see how, okay, that's the first degree. And then this is the second degree. You see how the estimation as you get closer to 0 is better and better and better? Then if I do this for the third degree, oh man, I can't copy and paste it. Right? You see how it gets better and better and better? But it's centered around this x equals 0. The more terms you use, the better and better approximation you would get. And in fact, theoretically, if you were to use an infinite number of terms, you would get the exact value of sine of x everywhere on the curve. Okay, But the point is, you see it's centered around this x equals 0. If you wanted a Taylor polynomial, the only difference in a Taylor polynomial and a Maclaurin polynomial is that it's not centered at 0. But if you want to do that, all you have to do is add an extra term. Let's say I want it centered around x equals 5. I would just do comma 5, and it would give me a different polynomial. These usually aren't as nice looking, just because the math doesn't work out as pretty. But you won't really see this too often. I think he maybe asked it once or twice last year. I might just be making that up though. Yeah, I think he maybe asked it like once or twice. But the main thing he'll ask for is these Maclaurin polynomials. Okay, we got two more things left. So I'm going to go ahead and clear this. All right, second to last thing is the differential equation solver. So all the way down at D, D for differential equation solver. So you click enter, and if you have a CX2, it'll pop up with this menu. If you just have a regular CX CAS, it's actually going to give you, like, just like it normally would, it'll say like DE solver and then parentheses. Just bear with me for a second. We'll get to that. So I'm just going to use this right here that they give us, y prime equals 2y. So the prime, right? If you've done any calculus, you know that the prime means that's the derivative. So if I want to solve the differential equation, like y prime equals 2y, in case you missed that, you get the prime by clicking this button right over by the g, and then over here, that's where you get to the prime. Y prime equals 2y, and then say your independent variable is x, your dependent variable is y. If you don't put a condition, actually, I'll show you what happens whenever you don't put a condition. It does it in terms of this constant. So it basically says, no matter what this constant is, it's still going to be a solution. But if you don't have a condition, then it doesn't know what to do. But if I go back and add a condition, say y of 0 equals 1, right? Then it gives me an exact solution. For those of you that are using just the regular CX CAS, it should pop up like this. It will say DE solve and then parentheses. And then you type it in just like you see it right here. The way you get the and is you literally just type it out on your keyboard. There's not a special place to go to for that. You literally just have to type it out. Okay, and then the very, very final thing, and by the way, you can do like higher order differential equations. It's not much more of a process, but he doesn't really ask it. If it turns out that later he wants to ask about higher order differential equations, it's a little bit outside the scope of high school math, but you know, I might update this video. All right, the very last thing, and this is in no particular order besides just the order it goes down the menu, but the very last thing is the implicit differentiation. So this is used to differentiate your like your relations, like your implicit functions, right? So a pretty good example of an implicit function is just a circle. So let's say we have the circle x squared plus y squared equals 9, right? And then at the very end, you just do comma x, comma y. If you do that, it'll implicitly derive it for you. You can use the while function out here. So let's say it's a pretty complicated equation and you don't want to like retype your x's and y's into each spot in your answer. You can do such that x equals 3, for instance, and it'll say, oh, now we have negative 3 over y. You can put an and out here and say x equals 3 and y equals 5. Click enter, and it'll put that in for both of them there. So you don't really need it in this scenario. I bet I could come up with a pretty complex different implicit differentiation. Maybe like 2x times the sine of y plus x squared. Something like that. That's pretty bad. Oh, it has to be equal to something. Equals 16. Right? And if you wanted to plug in like 2 and 4, like x equals 2, y equals 4, for instance, into this, it would be pretty annoying. Like you would have to substitute each thing in individually. But what you can do instead is do this. X equals 2 and y equals 4. And then you click enter. And of course, you might want to do control enter. Yeah, and then you click enter, and it does the whole thing for you, and it's much, much quicker. So that's about everything on the calculus menu. That's everything that I use like on a regular basis. This numerical calculations, not particularly useful. These other things in the series, not particularly useful. I will say that this is not a comprehensive thing of everything he could ask on the test. In fact, for things like the arc length, there is a formula that you're supposed to memorize for AP Calculus BC for the arc length of a function and for a parametric equation and whatnot. And sometimes he'll ask the question so that the only way you can answer it is by knowing the formula. Maybe he'll ask you like to set up the problem but not actually solve for the answer. And so you still have to know your formulas, right? This shouldn't be a substitute for knowing these formulas or knowing these concepts. These are purely meant for if you see that you can use it, then this is meant for speed. Of course, you can still use these, but before you start going to competitions, be sure that you really know these concepts, because that's where a lot of people will have their scores drop. So that is about it. Hopefully you learned something. There's a lot of information in this video. I'd highly recommend going a little more in depth, trying out different tests, seeing if you can find applications for these programs on your different tests. But yeah, if you learned something, make sure to leave a like and subscribe. If there's something you want me to go into more detail on, don't be afraid to leave a comment, and I will see you in the next video.